So this paper, you're gonna cut out all of the cards. So cut out all the lines here on this paper. All the lines. But on this paper, we're just cutting out around the outside so that we have our template. Okay? All the lines, just the outside. Let's go ahead and cut those out now because we're going to get started, and we're going to put these on page 26. Don't glue it down yet. I want to show you how to glue it down. Otherwise, you're not going to have enough room to write. That's my dog. Okay. So once you get the template cut out, we're actually going to glue it down as far to this side as we can get so that we have some room to write right here. Because we're going to write down exactly one sentence today. And then we're cutting out our cards. Yes, I know some of you were done. You already got started.
Mister, what if we have it on page 27? How do we glue it like that?
If you already have it on page 27, that's fine. Remember, it's your science notebook.
How do we glue it on?
You're gonna have to be a little bit more specific because my knee-jerk reaction is to tell you with glue is how you would glue that.
How would we glue it down to the page?
So you see how this one is like as far to the side as we can get it so that there's room right here? Just like that. We're just gonna glue it down like this.
So like as far as to this edge as I can get it?
Yeah, you just want to leave some room. So if it's like this, that's fine. If it's like this, that's fine. You just need some room here because we're gonna write down a sentence.
Okay.
As long as you have the room to write it down. Okay. And then when we get the cards cut out, we're going to sort them into an example pile and a definitions pile. Examples. Definitions. Because we're going to have to try to match these up from their definitions to their examples. Okay, if you're just joining us, we've cut out our template all the way around the outside of the template, and we're going to glue it down to page 26. And then we've cut out our cards and sorted them into an example pile and a definitions pile. Emily and Allison, do you have a question?
Yeah, is this good where I left 3 lines at the bottom?
Yeah, that should be good. Because it's not a long sentence that we're writing. It's just, we're going to just define when waves behave, kind of, if that makes sense.
All right.
Because there's a difference between a wave property and wave behavior. Box cross that baby down as far to one side as we can get it. Boom. I got all this room to write.
Miss Starrett.
My name most days. What's up?
I have no glue.
You have no glue.
Yes.
What about tape?
Yeah, I have to use tape too.
If you don't have tape, the other option is to take these definitions in pictures and just write them in here so that you don't have to glue it down. And then if and when we come back together, we can just cut this out around the outside and glue it down to your science notebook.
Okay.
Okay? A little bit of problem solving there. We'll get it done. Okay? So let's talk about wave behavior. Okay? I know a lot of you have already started the wave behavior questions because I was grading those last night. And you guys, most of you that tried it, you did a beautiful job. You did a wonderful job. good job on that. But one thing that I want to make very clear is that wave behavior is different than a wave property. So when we think about wave properties, we are talking about like the anatomy, the parts that actually make up what a wave is. Okay, these are the compressions and rarefactions. They are part of the wave itself. They determine how that wave is moving. They show us how that wave is moving. Wavelength and frequency, those are measurements of the physical wave. They're parts of the wave itself. When we talk about a wave behavior, these are the actions that the wave takes as a whole unit, okay? So when the wave is behaving as a unit, it can behave in a certain way. Just like you can jump or you can run, the wave is going to behave a certain way. And the certain ways that it behaves, the certain things that it does are, it can reflect, it can refract, it can diffract, and then it can experience interference, okay? And so that's what we're looking at here, is we're seeing how the wave interacts, how it behaves when it comes in contact with a barrier, because waves will behave only when they come in contact with a barrier. And so that will be like one sentence that we are going to write down. And that is, I'm going to go right here in this corner. A wave behaves, or acts, a certain way when it encounters a barrier. Now, a barrier can be like a wall, solid wall, just like a barrier is for you. You can't just walk through a wall, okay? But a barrier could also be like the surface of a pool. That's a changing of medium. A barrier might even be a different wave. It might be two waves coming in contact with one another. Okay, so probably the easiest one of these is reflection. What is the definition of a reflection? We're going to sort through these 4 cards that we have. Tell me, what is the definition of reflection? Lily.
I have a change in direction of a wave when it bounces off a surface or object.
Absolutely, you are correct. Now, I'm going to decorate this because it's bouncing. It's bouncing off of a surface. So it's coming in contact with, let's say, water. Who's ever been like sitting by the pool and the water is just kind of, or a lake even, and the water is just moving just a little bit and you get like blinded by those flashes of light bouncing off of the water. Yeah? Exactly. So that is experiencing reflection. So that's this one right here. So we're going to do that one there and that one there. And reflection is different than refraction? How is reflection different than refraction? Because these two are easy to mix up because of that R sound. These ones are easy to mix up because of the R. And I've already seen people mixing them up. Lily, you want to try it again? Yes, Michaela.
Because like
Go ahead, Lily.
Refraction is the bending of a wave instead of bouncing.
Exactly. Excellent way of describing that. So it's the bending. It's the bending of a wave. And that happens because its speed is changing. That happens because its speed is changing. So we're going to glue that one down. And then Michaela held this one up already. Is working ahead here. Whoops. This is an example of refraction. We can see that that wave is entering at a certain angle. And then once it passes this barrier, let's call it a window. Okay, once it passes through this barrier, whoop, its speed changes slightly, and so the direction of the angle changes slightly, just a teensy bit. So we're gonna glue that down there. Technically, I made them to fit this way, but that's fine. All right, now diffraction happens in a different circumstance than refraction. They both involve bending, but when are you going to experience diffraction? When are you going to experience diffraction? That's a good guess, Chase, but that's not the example. Emily and Allison, when are you going to experience diffraction?
You're going to experience it on the bending of a wave when it passes through a slight or around a slit, an edge.
Exactly. It's going to bend as it passes through a slit or like a small hole. Or around an edge. An excellent way to experience this idea of diffraction is to poke a hole through a piece of like black cardboard paper or black construction paper and then shine a flashlight through it. Okay. Now we've only got 2 examples left. Which one is going to be diffraction? Which one is going to be diffraction? Is it going to be A or B? Put it in the chat. A or B? Which one is diffraction? Ooh. Yeah, a lot of people are saying A. That is correct. So here is where the wave is being propagated. So this is the start. And then it's experiencing this wall, this object, this barrier. And then there's this little hole. And that is able to pass through. And then you can see that light, that wave, because usually it's light, that wave is expanding out as it gets further away. So that would mean that B is a representation of interference.
Miss Sarah,
Yes.
did I draw this good enough?
Yeah, that looks great. Okay, so our last definition is this. The combination of two waves to form a resultant wave of greater or lower amplitude. What does this mean? It sounds like a bunch of scientific gobbledygook. What does it mean? What do you think it means? By looking at the image, the example that we have, looking at this example, what does all that scientific gobbledygook mean? Emily and Allison?
Is it like does it mean like the waves are combining to create a bigger wave?
Yeah, like yes. So it's not necessarily going to be a bigger wave because remember it can be greater or lower amplitude. So it could be a bigger or a smaller wave. But yes, it's two waves interacting to create some sort of weird Franken wave.
Okay.
Yeah. So this is our Franken wave. This is my Frankenstein for my Franken wave. Okay. Okay. So remember, waves are going to do one of these four things. We just have to determine what is it experiencing? What kind of barrier is it coming in contact with? Okay. So we are either going to reflect, which is bouncing, refract, which is bending because of change of speed, diffract, which is bending because there is a slit or an edge, or it's going to interfere. It's going to create some sort of Frankenstein, some sort of Franken wave.